acids and bases. And you're probably familiar with this term, generally speaking. You certainly have heard the term acid before, right? What's an acid? Not chemistry-wise. You don't have to tell me like in terms of chemistry. Just in terms of like day-to-day life. What's an acid? It is something, as opposed to nothing. Well, when you think of the word acid, what do you kind of think of? Yeah, it could burn through my face or your face, because you said your face. Are you going to throw acid on my face? Is this what I get for not answering your question? Like, I'll show you not to answer my question. Boom, acid all over your face. Don't do that. Yeah.
It's a type of liquid.
Yeah, we think of it as a liquid. Good, absolutely. Type of liquid, and what do they do? They react with stuff, right? They can dissolve stuff. They can break stuff down, right? Good. Yeah. Does anyone know what we call the chemical property of being able to kind of break things apart, that they cause damage to things and break them apart? C word, corrosive. Good. Very good. So, acids and bases are chemicals that are corrosive when dissolved in water. So some acids are a gas dissolved in water. Some gases are a solid dissolved in water. Some acids are a liquid dissolved in water. Same with bases. But regardless, when they're dissolved in water, they are corrosive. And as a rule, we're going to make a little table here. And we're going to do a little bit of a note before, so don't worry about this first sentence if it doesn't make too much sense to you. But the first thing we're going to say is the definition of an acid is that they release H plus ions when dissolved in water. And again, we're going to make a little note of how that works and what it means. But for now, it's enough to say that for an acid, it is these little H plus. And of course, what's H? Hydrogen. And plus means that it's hydrogen that is given away.
Electron.
It's electron. Good. And hydrogen, how many electrons did it have?
One.
Just one. So this is actually a hydrogen nucleus with no electrons at all. So it's very small. It's just a proton. No neutron, no electron. One proton. We might even put that in a bracket. A proton. Physicists always talk about acids as releasing protons. Chemists always talk about acids as releasing H plus ions, and biologists always talk about that H plus ion sticking to water and forming something called H3O plus. You don't have to worry about that. But we're going to think of it as releasing H plus ions. But as it turns out, if you look at what H is, H normally is one proton, one electron. So you take that electron away, you're actually just talking about a single proton. Bases are different. Bases release a negative ion. Specifically, they release OH minus ions when dissolved in water. I said this last note. By the way, I lied. There's one more. I forgot about that because I changed the order of something I'm doing this year. Now, we haven't seen this before. It's going to lead into our lesson next time. But OH minus is actually a little covalent compound. It's oxygen covalently bonded to hydrogen, but it's given away and it's taken an extra electron. So it's got a negative charge. You don't have to worry too much about that. Acids, amongst other things, appear in food sometimes. Does anyone think of an example of a food that has acid in it? We actually used one of those yesterday, right? Something that we used on top of food. Vinegar is an acid. Anyone heard of citric acid before? Where do we find that? Lemons, limes, a little bit in oranges, citrus fruit, right? So what do those things all taste like? Sour. Good. Not that we're going to taste them in lab, but acids taste sour. Bases, on the other hand, soap contains a base. You ever tasted soap? What's it taste like?
It's nasty.
It is nasty. It's bitter. Bases taste bitter. Did anyone have a parent who actually did that? Made them put soap in their mouth when they swore? Yeah? I don't think I ever swore in front of my mother in my entire life. I think if I did, I think I am 41. I think she'd hit me.
I get like a tablespoonful of Tabasco sauce.
Well, that's what I was going to say. I had a buddy, my buddy Jay, his mom always made him take a shot of Tabasco sauce, and the guy swears like a sailor but really likes spicy food, so I don't think it was very effective. But
Maybe that made him like spicy food.
I think so. Yeah. Anyway. So maybe it was very effective, just not the law of unintended consequences. Do you know what the law of unintended consequences basically says? There's a rule that anytime you do something, whether or not the thing you want to have happen happens, there's also things that you don't expect to have happen that will happen. The law of unintended consequences. It's a good thing to remember. Acids tend to feel, how do I describe it? They almost squeak in your hand, where bases feel slippery. I'm not going to write that. But what I am going to say is this. These react with organic material, i.e. skin, cells, tissue like that, wood, things like that. All these things will react to acids and to metals. Yeah, so we can't put acids down the drain, because if you still have old steel pipes in your building, which, for example, we do on our walls here. Maybe I mentioned this yesterday. I don't know if it's this group or the other group. Was it to this group? Yeah, but somebody poured a bunch of acids down the drain in here, and like $25,000-$30,000 later, it was repaired because I had to dig up the wall and the floor, and the wall was made of concrete. So that was problematic. So no. I don't know who did it. But yeah. We came back from the summer at Zappings, and they taught summer school in here this year, so I wonder if it's a summer school group. I wonder if it was one of my classes. I don't know. But glad I didn't have to pay for it. But it is something you have to be mindful of. On the other hand, bases react with organic material. They don't react with metals, as a rule. This is why we put bases in our soaps, because they will clean like food stuff and things like that, but they won't react with your metal pots and pans and start eating away at them.
If your soap does, it's a bad thing.
Yeah, we don't want to soap. Now keep in mind that strong soaps, so the soaps we use for hand soap and things like that, are very mildly basic. They have a little bit of base in them. What we use for like drain cleaner and like oven cleaner has a lot of base in it. It tells you in the instructions to make sure you're wearing gloves, right? Because that's the next thing we're going to mention. Either acids or bases react more or less depending on how concentrated they are. What does concentrated mean? Does anyone know what that means? That is how much acid relative to how much water.
Or how much base.
Or base, yeah. So, for example, I am now old. I love orange juice, one of my favorite things. Currently swearing off orange juice because we're in a trade war with our neighbors in the south, which is where orange juice comes from. So I'm going to have to substitute with other lesser products, but I love orange juice, like my morning breakfast beverage. But you know what? As I get older, gotta be honest, I find it a little too sweet. Just a little bit. It's a little too sweet for me. So you know what I do? What do you do? Yeah, you water it down just a little bit. I like about 9 parts orange juice to 1 part water. So like 90% orange juice, 10% water. And this takes the sweetness off. Otherwise, it hurts my teeth a little bit. Yeah, sucks getting old. The point being, that's when we talk about concentrated. And then, does anyone buy? I have like a good job now, and so I buy 1 jug a week of like the more expensive, like good orange juice that's like fresh squeezed stuff. But I only buy the small one of that because I'm still a cheapskate. And then if we use more than that, you know what I buy? You buy the frozen ones, you know those? Come frozen in a thing like this, and you mix it with water and you add. Yeah, that one, they've dried some of the water out of it so that it can ship in a smaller container, like in a truck and things like that, and then they freeze it into these things, and you have to add water back in. It is extra concentrated. And then sometimes you buy something that looks like it's the good expensive orange juice, and then when you read on the label, it says from concentrate. And they're screwing you over because they're getting you to pay fresh orange juice prices, but really, they dehydrated it down to that, did the whole frozen thing, and then they just in the factory added the water, put it in the jug, and sold it to you. So you got to watch for that because then you're just getting ripped off. Yeah, keep your eyes out. But so the point being, concentrated tells you how much stuff there is relative to water. Does that make sense? And we measure how concentrated an acid or a base is on what we call the power of hydrogen scale. And hydrogen, because what makes something an acid? pH, power of hydrogen, H plus ions. So the power of hydrogen, and you'll never say that again, because what we always call it is pH scale. The interesting thing is that water doesn't have no acid in it. And that was a double negative on purpose. Water always has some H plus on it because water is actually a weak acid. Water itself can release H plus ions when it dissolves in itself. And as weird as this is to think, when you have some water in front of you, a little bit of the water, like a tiny little percent, actually gets broken apart and it acts as an acid. Which means that neutral water has about 1 part in, get ready for this, don't write this. Well, you know what, actually you can maybe. Neutral water has 1 H plus ion for every 0.1, 2, 3, 4, 5, 6. There we are. I should say. Has, I said backwards. Sorry. 0.0000123 4, 5, 6, and then that 7th number is a 1. H plus ion for every 1 H2O. In other words, 1 in, how big is that? 10 billion. 1 in every 10 billion water molecules will act as an acid. So even pure water has some acidity to it. Now, it just so happens that if you think about water splitting up, H2O, if we get an H plus, what's left from the original water? If it gets rid of one of its H's, it'll go from being 2 H's to being just So H2O, if it gives up one of its H's, what's left? HO. And we're going to write that, for whatever reason they don't write it HO, they always write it as OH. And if it's given away the H plus but kept its electron, the H ends up with a positive charge, which means this OH will end up with a negative charge. You don't need to know this per se, but it's actually interesting to know that water is an acid and a base. Because when it dissolves in itself, it releases an H plus ion, and that's the definition of an acid. But it also releases an OH minus ion, which is the definition of a base. Kind of weird, right? So now the good thing is it does this almost not at all. How much? Only 1 in every 10 billion, which means water is practically not an acid and practically not a base. But even still, it's a little bit of an acid and a little bit of a base. Does that make sense? It's an acid because it releases that H plus, and it's a base because it releases that OH minus. Having said that, we're not going to learn about them all, but we're going to learn about some acids that are common and some bases that are common. And the acids that we're going to learn about today are just the simplest things you can imagine. How many electrons does H want to give away? 1 to form an H plus. What are some things that want to take 1 electron that we could put with hydrogen? What's something on the other side of the periodic table that just wants 1 electron? Sorry? Helium has a full shell. Does it want any electrons? No, but you're on the right idea. So not helium, but no, nitrogen needs 1, 2, 3 electrons. Sorry? True, but that would be hydrogen gas, and that actually doesn't act as an acid or a base. That's a good guess. What else? Sorry? Fluorine wants 1. What else wants 1? Chlorine. What else? Bromine. What else? Iodine. And then astatine. We're not going to worry about astatine. So those make acids easily. If H and F come together, when you dissolve that in water, it will be an acid. So HF as a gas would be called hydrogen fluoride, but if we dissolve it in water, which means AQ, we would call that hydrofluoric acid. I'm actually going to put this basis below. I don't know why I wrote it there. It was a bad choice. What if we put H with Cl? This might be the most common acid of all. We use it all the time. We used it yesterday. What's it called? If HF we called hydrofluoric acid, that's its name. What do you think we call this one? Very good. Hydrochloric acid. By far the most common acid in the world. We use it all the time. It's safe, it's easy, it's cheap to make. You bubble chlorine gas through water, and it will make hydrochloric acid. So, nice and cheap. What about the next one, HBr? What do you think that one would be called when we dissolve it in water? As a gas, it'd be called hydrogen bromide. But if we bubble that hydrogen bromide gas through water, it will form... Yeah! No, that's good. Say it with some conviction, girl. Come on.
Hydrobromic acid.
That was good. I liked that. Very good. Hydrobromic acid. And what about the last one? HI. This one's tough to say. See if anyone can guess it. It's weird.
Is it hydroiodide?
Really close. Really close. Hydro, you put one extra syllable in there, it's just hydroiodic. Hydroiodic acid. Now, there are many more. Many, many, many more. There are many more acids that over your career you'll learn about. Some are covalent and some are ionic. But for today, we're just going to look at those ones. And then we'll look at some bases. And again, if bases are things that can release OH minus ions, then OH minus has a charge of -1. So they're going to pair nicely with things that have a charge of +1. So what are some of the things that could go with OH that have a +1 charge? Well, we already said HOH works, but we've already done that one. What's that called? HOH would be better written as H2O, water. So water is a base. It's also an acid. But what else? What else only wants to give away 1 electron? So it'd work nicely with OH minus. Yep. Lithium. Beautiful. So we could get LiOH. Now, as it turns out, OH is called the hydroxide ion. Hydroxide. So, which makes sense because it's a combination of hydrogen and oxygen. So they call it hydroxide. So, as long as it's dissolved in water, this is known as, well, actually, it doesn't matter if it's dissolved in water or not, but it's a base if it's dissolved in water because it'll kick off those OH minus ions. This is called lithium hydroxide. What's another thing on the periodic table that would work nicely with that OH that needs 1 electron to form? What else wants to give away 1 electron? We said lithium works well. Yeah, beautiful. What would that formula be? Sodium hydroxide. By far the most common base. What's its formula? What? Yeah, Na. And then you could write it HO, but we don't. We write it as NaOH. Yeah, we always do it as OH. Even though the name is hydroxide, the formula we always write as OH, which I've never thought about until this very moment, but that's kind of dumb, isn't it? But whatever, there it is. This would be called sodium hydroxide, and that will be a base. Potassium works beautifully, KOH. That's also a pretty common base. But again, by far, sodium hydroxide is the most common. Sodium hydroxide's in everything. Like all of your cleaning supplies, it just shows up all the time. KOH is potassium hydroxide. And we could do more, but these are really the 3 most common ones. Again, just like we said above, there are many more. These are just some of the most common ones. So now we can look at that pH scale, that power of hydrogen scale. Because the pH scale, which we talked about briefly yesterday, is a bit of a weird thing. It measures how much H plus is in the water. But here's where it's weird. It is, and you don't need to know what this term means, it's a negative logarithmic scale. Now, has anyone done logarithms yet in math? I can't imagine. You have. The rest of you have not. You don't have to worry about that. In fact, I'm going to put here, except you have to know 2 things about these, okay? The first thing is, because it's negative, this is stupid. Lower numbers equal not less hydrogen, more H plus. Now, is that kind of stupid?
Yeah.
Kind of. But you know what it comes back to? I'll come back to this, don't worry. Do you see how here, it's basically counting how many digits back you have to go. So neutral water, we have not 1 H plus ion for every water. We have decimal 0.0000001, and that 1 is not the first digit, not the second, not the third, not the fourth, not the fifth, not the sixth. That 1 is the 7th digit. So we say neutral water has a pH of 7. On the other hand, if something was much stronger, don't write this, so that it had this much, for every 1 water molecule, it released 0.001 H plus. Well, now we would say its pH was 1, 2, 3. We would say that has a pH of 3. Does that make sense? So that's how a logarithm works. That's why it multiplies, because we count by tens. You don't have to know that. You don't have to know this math until grade 12. So look at me. Look at me. I'm never going to make you do math with this. Not in grade 9, which is last year for you. Not in grade 10, which is this year for you. You're not going to have to do any math with this. Not in grade 11. You're not going to do any math with this. If you take grade 12 chemistry, you'll do math with this. But by then, you will have learned logarithms in math class, and this will seem easy. Does that make sense?
Or you'll do it like me and you take grade 12 and grade 11 year and you
And then I will teach you logarithms. And how'd I do? There you go. See, I get the Toby School seal of approval, and this guy knows what he's talking about. So, here's what you need to know. Lower numbers equals more hydrogen, so it's kind of backwards. And then, each step means 10 times stronger. So a pH of 6 is 10 times more acidic than water. A pH of 5 is 100 times more acidic than water. A pH of 3 is 100,000 times stronger than water, right? So this is the scale. At the middle of it, we have 7, which is neutral water. And we call it neutral water because even though it releases H plus ions, making it acid, it also releases OH minus ions, making it a base, which means altogether, it's equal part acid and base, and those cancel each other out. So we call it neutral. Anything below that is acidic. 6, 5, 4, 3, 2, 1, 0. And in fact, it can keep going. We usually stop at 0, but the truth is, the math doesn't say we have to. You can keep going. These are all acids. And each time, up here, we would have strong acids. Down here, we would have weak acids. Like we said, this is neutral water. What's a neutral color? Not red. Red's not a neutral color. Maybe yellow is kind of neutral looking. That's a neutral substance. And each step represents 10 times. So 4 is 10 times stronger than 5. How much stronger would 3 be? 10 times 10 is 100 times. Does that make sense? What if we went from 4 all the way up to 0? How many times stronger is that? 10, 100, 1,000, 10,000. Does that make sense? So every time you make a step on the pH scale, you're going up not by 10, 20, 30, 40, by 10, 100, 1,000, 10,000, 100,000, million, 10 million, so on and so forth. Strongs? I think that meant to say stronger. So each step means 10 times stronger. Now, on the other hand, if we go past neutral water, if we end up with releasing OH, not H+, that's going to go the other way on the scale. So bases go down this way. After 7, of course, comes 8, and that would be the weakest base. So these are weak bases. I mean, I guess the weakest base would be 7.00001, but you get the idea. And then after 8 would come 9, and then 10, then 11, then 12, then 13, then 14. And it does keep going, though we usually tend to think of the pH scale as going from 0 to 14. The truth is, you can go beyond that, but beyond that, you're dealing with extremely dangerous things. I have some pH -3 glacial acetic acid back there, and when I use it, I wear literally a little plastic bodysuit with gloves cinched onto those. I wear a little neck guard. I wear a full face mask and a shield. Like, it's serious business. The stuff is really nasty. Because at that concentration, it starts vaporizing up into the air, and it's so acidic, it will actually make the little bit of humidity in the air acidic and start to spread through the room. So I have to use it in the fume hood. You have to be very, very careful with it. That's not something you guys are going to be playing with, right? But in the range of sort of 7 to 0, that's all stuff that ranges from water, which is totally safe, to pH 0, we actually used yesterday. Nope, used 1 molar, which is pH 0. 1 molar, right? Because 1.0 is 10 times 10 to the exponent 0. So the log of 1 is 0. It's okay. You don't need to. But yeah, so you guys actually used pH 0 acid yesterday. I told you to be careful with it, but it's not going to go full Alien versus Predator and like burn through the building. So we have weak bases all the way up to strong bases. And you can look up charts of things, but like blood is mildly acidic. Milk is mildly basic. No, sorry, mildly acidic. It's got lactic acid in it. Your stomach acid has a pH of about between 0 and 1. So your stomach contains very strong acids. Your stomach is designed to handle it. Does anyone know what it's called if a little section of your stomach, the mucus lining that's supposed to be on there to keep the acid from damaging itself? Because left to itself, your stomach would actually digest itself. The acid in it is designed to break down proteins and stuff. It would destroy itself. You have a little mucus lining, but you can develop something called a peptic ulcer. Anyone ever heard somebody having an ulcer? That's where a little bit of the lining of the stomach wears away, and now the acid can start to eat into the stomach itself. And if that's left untreated, it can get serious enough that it can actually burn right through your stomach. You can end up with a hole in your stomach, and that can kill a person. You've probably at some point in your life gotten that stomach acid into your esophagus, into your like the tube that food goes down. You ever experience heartburn? That happens when the valve to your stomach that's supposed to close to make sure the stuff in the stomach doesn't come back up opens for some reason, and some of your stomach juices, the stomach acid, we call them gastric juices, gross word, make their way up into the esophagus and they burn the lining of the esophagus. If it happens just for a few minutes, it's very painful. If it happens for long term, it's dangerous. It can, again, eat away at that tissue. You know when you throw up, how gross your mouth feels? Beyond just the taste is awful. But you know how you get that thing, that really kind of gross feeling? That's some of the stomach acid from your stomach. And if you don't rinse your mouth out, wash your mouth out, brush your teeth well, it'll start to eat away at things. People who are bulimic, everyone knows what bulimia is? Bulimics are people who induce vomiting regularly as a method of sort of controlling weight, most typically. Though there's other reasons people may induce vomiting frequently too. But they tend to have really, 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 really bad teeth and gum problems because they're constantly exposing their mouth to stomach acids. And acids break down organic material, right? So something to be mindful of. But bases, again, can range from very, very mildly basic. Soil, for example, tends to range somewhere between pH 4 and pH 9. So soil can be mildly acidic and mildly basic. Different plants grow well in different acidities. Plants that come from natural places like near volcanoes and have volcanic ash in it, that tends to be acidic soil. And so there's certain plants that grow well in acidic soil and don't grow well in basic soil. And then some things grow well in basic soil. So often if you're having trouble growing a certain type of plant or a certain type of tree, and you call up an expert and be like, why can't I get this thing to grow? They'll ask, well, have you tested your soil for acidity, right? Because you can change that with different treatments. Yeah. And then the last thing we want to look at is reactions of acids and bases. And these are pretty cool, actually. These are really cool. We're going to do some of these. Definitely, we may or may not get to a lab where we deal with this in this class. I went back and did some of the grade 9 labs with you because they're more fun and you hadn't done them. So we might not get to this one, which is less fun, but still kind of cool. But reactions of action, acids and bases are interesting because, well, you'll see. So we're going to pick an acid, and I gave you 4 acids, right? Hydrofluoric, hydrochloric, hydrobromic, hydroiodic. Pick one. Doesn't matter which one. Hydrobromic? Done. What's the formula for hydrobromic acid? HBr, right? And remember, it's that H that makes this an acid, because when it's dissolved in water, it can let that thing go. It can release it. It can be dissociated, is the term. Give me a base. I gave you 3 of those, I think, right? Did we say lithium, sodium, and potassium hydroxide? Doesn't matter which one. Give me one. Pick one.
Sodium.
Sodium it is. Sodium hydroxide, what's the formula for that again? NaOH. Yeah. And this is our first time dealing with what we call a radical, where the ion isn't just one atom. The ion is actually 2 atoms stuck together. That's okay. We're going to deal a lot more with them, with what is actually the last lesson in this unit, which we're going to do on Friday this week. But if we look here, there they are. And what's going to happen is this is just a double displacement reaction. And you've seen this dance before. Acids and bases. So why am I saying this is? I'll say acids and bases react via double displacement. And double displacement, remind me what that means. We got two couples that are out on a date here. Hydrogen's on a date with bromine. They're acidic. Sodium's on a date with hydroxide. They're basic. Well, in a way, both of those things are a way to insult somebody, aren't they? But that's okay, because what's going to happen on this date? In double displacement, what happens? Remember, in single displacement, I get dumped in an Arby's parking lot for somebody who works at an Arby's, hypothetically speaking, of course. But in a double displacement reaction, what happens? Yeah.
They switch.
They switch partners. And who's hydrogen's partner right now? Bromine. Well, who's hydrogen going to end up with? Not bromine. Switching out partners. Can hydrogen end up with sodium? Nah, they're both positive. So who's hydrogen going to end up with? OH. HOH. And of course, is there a better way to write HOH? Yeah, that's just another way of saying H2O, which is just another way of saying water. So, if you mix an acid with a base, one of the things you get is just water, which is why acids and bases neutralize each other. It's why if you ever spill an acid, I'm going to go get a base and cancel it out so it stops being dangerous. If you spill a base, I'm going to go get an acid. And in fact, in the back, we have some kitty litter that has acid in it, so that if you spill an acid, I've got this stuff that I can pour on it, is basic, and it will cancel it out and make water, and it'll also clump up and make it solid so we can just clean it up with a dustpan and put it in the chemical waste disposal. Much easier than dealing with liquids, right? And I also have a kitty litter back there that has acids in it, so that if you spill a base, I can pour that on it, and it will bubble up a bit, and it'll do its thing, and it will form water. So we can take an acid and make it harmless by adding a base. We can take a base and make it harmless by adding an acid. Now, we are going to end up with something else. Who does sodium end up hanging out with? Sodium ends up hanging out with bromine. And of course, we have to do a quick check. How many electrons will sodium want to give away? 1. How many electrons does bromine need to take? 1. Do I even need to draw a chart? Now, what's the formula for sodium bromide? NaBr. And this is sodium bromide, which is just one example of what we call a salt. You're used to thinking not a salt, but a salt. So you're used to thinking of salt specifically as sodium chloride, but the truth is anytime you mix a metal with a non-metal and you get this 1-to-1 ratio, those are called salts. So sodium chloride is a salt, sodium bromide is a salt, lithium fluoride is a salt, lithium bromide is a salt, potassium fluoride is a salt. Anytime you mix group 1 with group 17, we call those salts. In this case, the specific salt is sodium bromide. How's that? Not too bad? Let's try another one. This time you can do it. What if we reacted, potassium hydroxide with, and I'm not going to color code this one, make you figure it out, with, let's say HCl. So the first thing you'll notice is this time, just for fun, I switched the order. In the previous one, what did I put first, the acid or the base? On this one here, it's the acid. On this one, I put the base first. How do we know this is an acid, not a base? It has hydrogen, whereas this has OH. And what do we call OH again? Hydroxide. Good. In fact, I'll probably write that again. Hydroxide. What's that? Focus on me. Not them. Come on now. I'm the center of attention. If I ever told you guys one time, very embarrassingly, has anyone seen the movie Batman Begins? No? It's a good movie. You should watch it. It's better than, I would say, most superhero movies. I'm kind of over most superhero movies. They're kind of getting boring to me. But Batman Begins, it's a good one. But anyway, in it like tells the story of Batman becoming Batman. And there's a scene where it's like his first time out, and he's catches this drug dealer, and he's like dangling him over a roof, like over the side of a building. And he's like, "Where are the drugs?" And the guy's like, "I don't know, I swear." And this is the Batman series where Batman did like the big like voice, like where he did like the real low guttural thing. So it's a good scene. He's like, "I swear, I don't know, I don't know, I don't know." And then he says, "I swear to God." And Batman goes, "Swear to me," and then drops him. And then he catches it. He has a rope around him and catches him at the last minute. So he doesn't actually kill the guy. But it's like iconic kind of moment, right? I swear to God, swear to me. So about 4 years ago, this girl's on her phone in my class. So I get the box and I take the phone. She rolls her eyes and goes like, "Oh, I swear to God." And I said, "Swear to me." And then I quickly, like in one of those moments where like in the blink of an eye, you realize like, I don't think they know that reference. And she was looking at me real funny. And then I was like, you know, like Batman. That's like, anyway, then I was like, okay, never mind. And I just walked away. It was very awkward. I was very embarrassed. Anyway, that's the end of my story. Okay, I want you to do this double displacement reaction and tell me what you get. Why do I tell these stories? You know, it occurs to me that 50% of the reason I look stupid to people is because of what I do, but then the other 50% is because I tell them about other things I've done that they don't have to know about.
You also recorded this one.
I record them all. Anyway, that's a true story. I told some like 14-year-old girl, "Swear to me," after she said "swear to God," and I was like, yeah, anyway, and I was embarrassed. Shut up, do the reaction. Get to work.
Now I'm curious. You said that if you mix 1 and 17 together, you get a salt. But what happens if you mix like 2 and 16 together?
We also call those salts, and just keeping it simple for great time. Yeah. Ionic salts are just ionic binary compounds, but
Yeah.
keeping it simple.
So like aluminum nitride.
Yeah. Go, give it to me.
Wait, no, I'm trying to think of.
Okay, put it together. Put it together. You need the punchline to be a salt.
Yeah.
I'm wondering if there's some way to work in, like, because we use ionic salts when we make battery cells. So, like, to get to a salt and battery, I really think you can make this work.
He's just trying to get us like do everything for
Shut up. Yes. First of all, yes, correct. Second of all, why you gotta put it out there like that? Be quiet, you.
I don't know. I gotta think of it.
Talk to Calford. That guy's a pun factory. Sorry?
You made a dad joke the first time I got there.
Oh, disagree. I love that guy. He's one of my favorites. He's a good friend.
Apparently,
A good man and a good friend.
apparently for our county.
And the DSBN's best. And the DSBN's best math teacher. That's something you guys don't realize. Like, take it, like him, don't like him, cup of tea, not your cup of tea, but objectively, Tim Calford is the DSBN's best math teacher. The guy's a friggin', he's a maniac. Yeah, no, like, to be clear, that's not to say that he has to be your cup of tea or your favorite teacher. That's why they have menus in restaurants. But if you're interested in becoming an elite math student, like if you really want to be the best of the best, he's the coach you want. You know? And that's not everyone's interest, right? Like, and it doesn't have to be your interest. But in the end, like, if you wanted to be the strongest math student possible, he's the guy you want. He's brilliant. He's so creative in how he approaches things. And his ability to, like, bring that out in people is really second to none. Everyone in the DSBN uses Calford stuff. Whatever school you go to, like, half of what they're using is stuff he's made. Like, just his stuff is everywhere.
For calculus, the last unit test, he took it from some other teacher, and that's why we had that awful logarithm one.
No, we all take from each other. Like, that's, I mean, I don't, because I'm megalomaniacal, and I have this compulsive need to feel like if I don't make it, it's not good enough. It's not even that, it's just fonts. Like, I get other people's stuff, and it's so ugly, and I'm like, why would you pick these fonts? And I'm like, I gotta make this myself. And it's like, by the time I take yours and edit it so I think it doesn't look like hot trash, I could just have made it myself. Just give something else. Teachers really love, like, clip art and emojis and then those stupid bitmojis and stuff, and that's just not my style. I'm not into it. It doesn't do it for me.
Speaking of puns, apparently on our...
Yes, ma'am.
The thing you were doing in the first period, was that the flame thing? The color thing? The copper?
Yes. Yeah. Yeah, so they have to go a little step further with it than you guys, where they do that and another reaction, then they have to kind of bring the two together. Do you know, some years in grade 11 chemistry, I've done this final lab where they start out with copper, and then they have to go through a series of 7 reactions, turn it into a whole bunch of different things, and at the end to turn it back into copper and see how much of it they can recover. I used to love that lab. It was a really good one. And like the first thing they have to do is just physically mix it with a bunch of stuff. So I literally give them like wood chips and sand and salt and all these things. And I'm like, all right, now you got to mix it in there. Now you're doing this reaction, that, and at the end they have to filter it. They have to, all these things, but you have to get back to being, your job is to give me as much pure copper at the end as you can. It was a good lab. Okay, what do we got with this? What's going to happen? Again, what kind of reaction is this? We call it an acid-base neutralization, but that's just because it's an acid and base. It's really just... yes, correct. Which means they're going to do what?
They're going to cheat on each other, basically.
Sure, but like mutually, like cheat on each other with each other. It's like that song, like the stupid like, if you like pina colada, you know that one? And getting caught in the rain. And then like the whole punchline is he's trying to cheat on his wife by answering a personal ad, and then at the end he discovers it is his wife who put out the personal ad. Do you know this? That's right? So that's weird, right? It's like, oh, you're trying to cheat on me. I was trying to cheat on you. Are you allowed to be mad about that? I don't know. I think they end up happy at the end, which strikes me as not very realistic. You know? Anyway. I don't know. So yeah, they are going to swap places, which means H isn't going to end up with Cl. What's H going to end up with? OH. And again, how would we... I'm going to write it this way, even though that's silly, just so you can really see that they've swapped partners. So how would we actually choose to write that? H2O, right? This isn't wrong, but it's clumsy. And then what's going to end up together? K and Cl. And we can work that out. How many electrons does K give away? 1. How many electrons does Cl want to take? 1. So we don't even need to do any numbers. This will just be KCl. Right? Nice, easy ones. So acid-base neutralizations are easy. Now, we will build up a little bit later in our next lesson, and then certainly next year, into acids that have more than one hydrogen, where we'll look at things like this, where it has 2 hydrogens to give away, or H3PO4, where it has 3 hydrogens it can give away. But the principle is still the same, right? Which is you can neutralize an acid with a base. So the big takeaway is acids and bases neutralize each other. Forming water and an ionic salt, which is just another way of saying an ionic compound, like we said. A binary ionic compound.
I can't read
What word?
my own writing.
Oh, okay. Can you read mine?
Yeah.
Good. It's a little messy today, I'm sorry. Somebody said my A's are looking very 2-like lately, and I can't disagree. Yeah, I don't know why I was taught. Sometimes I just do this one. So, because that's like a cursive A, right? So sometimes, because I also always write in half cursive, so just like I sometimes write T's, or like I'll do TH like that. Sometimes I do the kind of cursive A, but my printed A, it's like that. Isn't it weird? Like, you ever actually think it's weird that in your brain, without you ever having to think about it, knows that this and that and that and that, right? And like people do fancy ones like that, right? Or like something silly. Like your brain just doesn't even have to process that those are all the same thing. Isn't that weird?
See, I always see the A with a hat. My mind immediately goes to like, is that Russia? Because that's the exact, like every Cyrillic.
That's true.
And Cyrillic, that is how.
That Cyrillic alphabet's super cool. I like that Cyrillic alphabet.
I got told one time that my capital A's look like easels, and I like practiced drawing them up like easels, and now they don't look like easels.
Can I see? Can I see an original one? Yeah, I can confirm. It's like this kind of thing.
Yeah.
Yeah. Now you just need to draw in like.
They still don't look like they look like actual A's now. Like that.
Good morning, Eagles. On today's cafeteria menu, we have.
That's what I was thinking, and then I kind of gave up.
I was thinking like easel from the side angle.
You've never seen the real Starry Night? I saw it in New York City a few years ago. You've never been to MoMA? If you ever go to New York City, you can go to MoMA. It's like $4 to get in. It's cheap. The Museum of Modern Art. And you can see like the real Starry Night. You can see Guernica. You can see like all kinds of stuff. They have a theater in the basement where they show like films, like experimental films. Really cool. Very much worth going to.
I did this art and
Okay, so guys, listen. What did I call yesterday's stupid lab? Lab 0.2? I'd like that tomorrow. It shouldn't take you a long time to write it up. It's a pretty simple one. But I'd like that for tomorrow, please. Yeah. Have a once the bell rings, obviously not before. Have a wonderful day. Be kind to one another. Don't do anything Toby wouldn't do.
Speaking of comes from here, Calford has apparently, in the comments of all of our progress reports, done calculus check.
Yes.
I haven't gotten them yet, so I don't know what they are.
I let me say, it was very cute. I don't think you're going to find yourself like rolling on the floor with